Hi, my name is Mark Jessop. I'm a member of the Amateur Radio Experimenters Group, which is an amateur radio club here in Adelaide. And I'm also a member of Project Horus. And we do high altitude balloons. And, uh-oh. Help. There we go. All good. So, high altitude balloons. These are specialized latex balloons, similar to your regular kind of latex party balloons, but much, much, much bigger. So these are mostly used all around the world for meteorological observations, weather prediction. So twice a day, out of Adelaide Airport, the Bureau of Meteorology launches balloons, not very different to that, with these devices underneath them. They measure temperature, pressure, humidity. As they rise through the atmosphere, the balloon eventually bursts and drops back to Earth. All that data is used to go into worldwide weather models to help predict the weather. So hobbyists have been launching weather balloons for various purposes since around about the 1960s and 70s, and they've had various different uses for them, scientific experiments, testing out radio repeaters, but I could spin something about going to near space and et cetera, but really it's all about the really, really cool pictures, all about the pictures. So almost every high altitude balloon launch has some kind of camera on it, or a video camera or a stills camera, and up around about 30 kilometers altitude, you're above about 95% of the Earth's atmosphere. As you can see in this picture, you can see the blackness of space. And obviously you can get a wonderful view of our state. So on the left there is Yorke Peninsula, and Adelaide somewhere underneath some cloud there. You can also potentially see the curvature of the Earth. More than likely you're seeing the curvature of the fisheye lens of your GoPro camera, but it still looks pretty cool nonetheless. So Project Horus was started in roughly about 2009 by a guy called Terry, who's sitting up the back there. Hi, Terry. And Terry's aim was, he saw MIT and some groups at MIT and other areas had done similar launches for a price that seemed really, really cheap. As he found out, it's not actually that cheap to do a high altitude balloon launch. So he spent a long time developing it, getting the appropriate approvals with CASA, which is a key part about what we do. And in early 2010, he did his first high altitude balloon launch. And there's Terry sitting there in the center with his balloon. And that got to about 30 kilometers altitude, had a camera, took some great pictures, and also started the first test of a tracking payload, which I'll get into in just a minute. As of this month, as of now, we have performed over 40 balloon launches, mostly out of Mount Barker. We performed launches for other groups as well. So for example, the University of Sydney had a CubeSat demonstrator. University of Adelaide, Uni SA, we did a STEM outreach launch in Burra, where we had students from all around South Australia attend and take part in a very large balloon launch. We've launched for Lonely Planet, Rising Sun Pictures, where we captured reference imagery, which was used in the movie Gravity. More recently, we've done launches for Uni SA and the International Space University as part of their Southern Hemisphere Space Studies program. So again, teams of students designed payloads and we launched them for them. We've also done launches for a group called Launchbox, who work with high schools around South Australian area, and they design science experiments in kind of a CubeSat form factor, which we've launched into roughly to about 30 kilometers altitude. So one of the key parts about a high altitude balloon launch is tracking it. If you fill up your balloon and put your camera on it and let it go, you've launched a very, very expensive party balloon. Clearly you have to have some way of tracking it and recovering it. So over probably about the 6 years that we've been working on this project, we've developed a range of radio tracking systems, and they're almost all of them are based on Arduino. Originally it was actually an Arduino board with a couple of shields attached to it, GPS receiver, a radio transmitter. Now we design our own PCBs, and they all operate on one of the amateur radio bands. And they're received by amateur radio operators all around the state, and around the country, in fact. One of the interesting parts about the way that we do our balloon launches is that anyone, or any amateur radio operator, or people who have the right equipment, which is fairly cheap nowadays, can receive the telemetry from the balloon, upload it to the web, and provide additional redundancy for our balloon launches. So, for example, if in our cars, which might be fitted out with lots of equipment, if we have an equipment failure, we can log onto this website, see where the balloon is, because other people are also uploading the position. So in this particular example, in the centre of the image, you can see the location of the balloon, and the green lines show the paths to all the different receivers all around the southeastern part of Australia. So we have receivers all the way from Adelaide right around to Canberra, all tracking our balloons and seeing where they are. This is not a normal launch. Normally we don't go into Victoria. That's a long way to drive, but just an example. So a bit of a walkthrough on what happens on a balloon launch day. So we're going to arrive at our launch site fairly early in the morning. We generally launch from Mount Barker, more recently Mount Barker High School, and we'll fill our balloon. And we have a number of payloads. It could be telemetry systems, could be video cameras, all sorts of different things. And we have to put just the right amount of gas into the balloon for it to rise and eventually burst at an altitude that we want it to burst at. So once the balloon's all filled, we'll let our payloads go. Once we let it go, that's it. We're not getting it back again unless everything works as planned. Then we hop in our cars, which have been tricked out with all sorts of interesting radio gear, and go drive after them. So that map we showed you before, we can see where the balloon is. We can predict, based on the current wind conditions in the atmosphere, where it's going to go. And ideally, if all goes well, arrive at the landing site before the balloon does and watch it descend to the ground. In the centre there's the parachute. There's one of the payloads descending to the Earth. So of course there's a parachute. If all goes well, the balloon will burst at the altitude we set, and it will land in a wheat field somewhere to the east of Murray Bridge at a nice, gentle speed. And we go and recover it. So there's a lot more that I couldn't fit into this talk, but we have a stand over in the Creative Court. Look for the big red balloon. Can't miss us. And yeah, come and ask us questions and find out more. Thank you.